Hello everyone. In this session, we'll discuss on artificial intelligence. Specifically, we'll talk about what is artificial intelligence, or AI, where it is used, and what are the techniques. During the process, we will simplify the whole concept, and give you a holistic perspective. So, let's get started. We, the human being, are intelligent, and can take decisions intelligently. But often, we are not very fast at computation. Like, we cannot handle a lot of data, or a complex calculation very fast. On the other hand, a computer system is 10 million times faster than human being, in terms of processing speed. But, a computer cannot make decisions on its own. Rather, it takes decisions from us, and simply executes them. So, what if, making a system, by combining them both? It's like bringing the intelligence of human beings, into a computer system. Isn't that going to be great? Well, that is simply artificial intelligence, or AI. Think of a self-driving car. The car can navigate the road, traffic, follow all traffic rules, and can reach the destination, safely on time, without any human being actually driving it. So AI is a computer system, that can mimic human beings, and can make decisions, without human intervention. Today, AI is a buzzword, and creating a lot of waves almost everywhere, including the job market, industry, entrepreneurship, our daily life, large enterprises, and so on. Now, there are three important areas, where AI is mostly used. Automating business processes, like back office and customer engagements. Gaining insights through data analysis. And building value-added next-generation technology. Let's see with a few examples. I'm sure you must have seen chatbots in any banking portal. The bots can automatically handle your queries, quite efficiently, and with reasonable accuracy. They can update your address, change phone numbers, block your lost credit card, read data from email, and handle basic levels of queries. In many cases, they also help you to resolve password and login issues, document verification, and updating records in all systems. These are examples where AI helps to automate business processes, and support back-office productivity, and improving customer engagements. Next, AI is used to build predictive and prescriptive models, and helps us to get actionable insights from data. Some common examples are predicting which customer is going to churn out, which item a particular customer is going to buy, identify a credit card fraud transaction in real time, showing the most relevant ad to a target customer, real-time product recommendation, and so on. Finally, there is a significant growth of AI-based technology to create value, such as image and video processing, natural language processing, and speech recognition. Today we have tools for detecting objects, recognizing speech, translating languages. We have text-to-speech, speech-to-text, AI-powered games, automated guided vehicles, robotics, and so many other examples, where we use AI. According to an estimate, the AI industry is going to worth $400 billion by 2025. No surprise, why it is so important today. In short, AI is one of the most important drivers to influence human life, post-internet. And the success of AI is attributed to cutting-edge scientific algorithms with high-performance computing, at a very low cost. The next question is, where does the intelligence part come in, artificial intelligence? Well, the intelligence may come from any natural sources. For example, think of an army of ants. While searching for food grains, they divide into different groups, and search in different directions. During the process, they communicate with their peers with pheromone, a special chemical footprint. Once an ant finds a food grain, the rest gradually come to know about it, from the pheromone density on the surface. Finally, they all reach to the food, and carry it to their storage location. The way ants divide into groups, searches for food, and finally communicates with others, has been deployed by researchers as ant colony optimization. Similarly, we have artificial bee colony algorithm, based on the behavior of bees in a beehive. Both ant and bee colony algorithms are used to intelligently solve complex optimization problems. This is known as swarm intelligence, a form of artificial intelligence. Next, we have fuzzy logic. Fuzzy logic mimics how human being makes a decision. For example, if you want to cross a road without a traffic signal, you care about the speed of the on-road vehicles. You just care if they are fast or slow. At that time, you don't try to measure the actual speed of the vehicle, like 60 or 80 miles per hour. You simply estimate if an approaching vehicle is slow or fast, to allow you to cross the road. And accordingly, you decide your actions. That means, our brain makes decisions more judgmentally than mathematically. Fuzzy logic converts a mathematical number to a judgmental estimate, and helps to mimic our decision-making process. Fuzzy logic is widely used to make human-like decisions, amidst unclear data in real life. Artificial neural network is another important element within artificial intelligence. Artificial neural network is inspired by human brain structure. The difference between fuzzy logic and artificial neural network is that fuzzy logic mimics how human being makes a decision, while artificial neural network is based on how the human brain is structured. Well, the human brain is made of several billion interconnected neurons. Every second, our brain is exposed to 11 million bits of information through our senses. The information is passed through neurons in the form of electromagnetic signals. Each neuron sends signals to the next neurons in a network. In a junction, all signals are added up, processed, and if the net signal is significant, it flows through, else suppressed. At the final end, the resulting signal triggers the right action. The artificial neural network represents how the human brain works. The computer model is designed as a complex network, where the input information passes through several processing layers. During the flow, the information is added, transformed, and processed. And finally, an output is derived at the end layer. As you can imagine, artificial neural network definitely requires a massive computer processor to build a working model around it. Hence, though the concept was designed in the 1950s, the lack of computer infrastructure prevented its growth and popularity. And it is only in recent times, when we see significant application and efficiency of artificial neural network, thanks to the powerful modern computer infrastructure. Another important element of AI is machine learning, or ML. Machine learning is primarily used to solve predictive and prescriptive problems. ML is all about learning from data. It is similar to how human being learns. Human beings learn through experience. And a machine in ML learns from data. That means, you give a lot of data to the machine, and the ML algorithms will come out with hidden relationships, or patterns within the data. And that is how the intelligence come. Let's see through an example. Imagine, you are given a simple demand-price dataset. Your manager now asks you, if there is any relationship between them. And what would be the demand, if we set the price at $20? Well, if you look carefully at the data for some time, you can clearly see that demand is dependent on price. Like, once you have got this relationship, you can go ahead to find that demand would be 31 units, if we set the price at $20. Now, in real life, the problem is not as straightforward. You may have so many other factors like customer income, competitor price, competitor demand, macroeconomic factors, just beside price to influence demand. Secondly, their relationship is not that simple. Hence we need ML algorithms that scan through the data, and finally provides the best relationship, or patterns as discovered from the data. There are several ML algorithms that help us to get the relationships. ML is a strong pillar within AI, and can be used with other domains to create separate branches within AI. For example, ML with linguistics created a new road called natural language processing, or NLP. NLP imparts intelligence to computers to process text data, like sentiment analysis, document classification, and analysis of large amounts of natural language data. Similarly, ML with image processing created computer vision, a field that makes a computer recognize images and videos. Recently, artificial neural network with massive computer architecture, to its own credit, became a separate field. This is known as deep learning. As you can imagine, deep learning is a method of building complex neural network that involves a lot of data processing. To make it simple, there came TensorFlow, a mathematical engine with inbuilt data structure and machine learning algorithms as the foundation. On top of TensorFlow, there is Keras, an interface to build complex neural networks. To run complex machine and deep learning models, we also need the right hardware, where we have CPUs like Intel Xeon. Next, GPUs like NVIDIA Tesla P100. And TPUs like Google TPU v3. What are they? Intel and AMD make processors or CPUs. Usually, CPUs come with 4 or 8 cores, and CPUs are good for general purpose use. But complex deep learning models require more computation power. Hence, NVIDIA has come up with graphic processing units, or GPU, dedicated to deep learning. It has hundreds of cores for parallel processing. Using these, you can easily run deep learning algorithms efficiently. Now, Google has created similar powerful processing units like GPU, called Tensor Processing Units, or TPU. TPUs are deployed in the cloud, so that you get maximum power of cluster computer. TPUs are extremely powerful to efficiently run complex machine and deep learning models with TensorFlow. To summarize the discussions so far, AI is the superset of all methods to add intelligence into a computer system. Within it, we have techniques like swarm intelligence, fuzzy logic, artificial neural network, machine learning, deep learning, NLP, and computer vision. We also have robotic process automation, called RPA. These are mostly rule-based systems, and there is not much learning, as compared to other AI techniques. So, how AI, machine learning, and deep learning are related? Well, deep learning is a subset of machine learning, and machine learning is again a subset of AI. So, whatever intelligent things we do, mostly fall in the broad field of AI, and depending on its approach, logic, and algorithm, it can further be classified into any subsets within AI. Hope this gives an idea of what is AI, and the important domains inside it. In the next session, we'll talk about machine learning, and see how typically a machine learns. Stay tuned, and I will speak to you soon. Thank you.